Welcome back to my channel. I'm Brian Kapke, and I'm excited to get into the topic of using the upsert statement in SQLite. What is an upsert? It combines an insert and an update in a single statement. I do want to point out before I start that all statements and opinions in my videos are my own. And for those interested, I appreciate anyone who would like to help support me on Patreon, where you get access to me, ad-free videos, and more, all for your support. So where are we going? What is an upsert and why do I care? And I want to talk a little bit about the tools of the trade, and then we'll get right into the tutorial. So this will be pretty quick. Let's start with the problem. What are we trying to do with an upsert? Well, we've got this thing we need to do, which is database table maintenance. So generally speaking, you have a data warehouse, right? We're all data analysts and data engineers, right? So we have a data warehouse, and we have to maintain tables in that data warehouse. So you can picture here, we've got a SQLite database, but this could be Postgres or SQL Server, Oracle, what have you. And the idea is we need to maintain a table. And to maintain that table, and I'm going to use the example customers, we need to maintain the data. We're going to have adds, changes, and deletes. Adds mean that new customers come in and we need to add them into our table. Changes mean that information changes. Maybe they got married, their name changed, or a salary changed, or we have information like that. So we need to update that information as well. And sometimes we're going to remove customers. We don't want to have them on our list anymore. So those are the types of transactions we can have. We take those transactions and we apply them to our master table in our data warehouse. And it can come in the form of a flat file. That's not uncommon, like JSON, CSV. But more often than not, a data warehouse is sort of a reconstruction of data that came from a transactional database. In other words, transactional being the systems that actually support the business, like finance, order entry, accounts payable, etc. So we get that information and we want to bring it into a data warehouse where it's probably remodeled to be a dimensional model, but it's basically the same data. So the idea is we want to take the data that's coming in and apply these changes to it. Now, the traditional solution, which isn't much different than what we'll be doing, is we would use an insert statement to perform the adds. We'd use an update statement to apply changes, and we'd use a delete statement to remove rows. But we want to show you here is that you can combine the insert and the update in a single statement. It's less code, and I think it's also more reliable because it's going to combine the two together. Why do I care? Well, makes your life easier, right? Less code is better. It's a single statement. It's also good to be aware of. It's good to know that upserts exist. Most databases do have something similar to an upsert or the upsert itself, as we'll see here. It's also really good to be aware of just so you have another tool in your toolbox. The other thing I want to mention is consider using SQLite Studio, of having a user interface, a GUI, for the database I work with, regardless of what other programming I'm doing. And just a way to sort of augment your development work. Now, this notebook that we'll be walking through and the data will be available to you on GitHub. I'll put a link in the description so you can go and use it for yourself and play with it. But I always have to put a disclaimer. It's for demonstration purposes only. What does that mean? It means I didn't design this or think of this being directly put into production. It could have risks. I haven't thought much about security. I'm just trying to teach you something. So if you're going to use it, then it's your responsibility to make sure this code is safe, secure, and does what you want to do. You can follow this link to get to documentation on SQLite, and let's get right into the code here. First thing I want to do is import the SQLite library, which is SQLite 3. Then I'll just do a couple of these print statements that will tell me the version information, and I'm going to bring pandas in just because it'll be available to me. We can see now the versions we have. SQLite 3 version is this version, and my SQLite version is here. And that's good to know because I can't do an upsert unless I have at least 3.24.0 of SQLite. And guess what? I do, so I'm good. So the first thing we always need to do, pretty much when we're doing any database connections, is connect to the database and then save our connection information to this connection object, which I'm going to call intuitively CONN, the connection. So here we have the connection object, as I mentioned. We're going to call SQLite3.connect, and then we're going to tell it what is the database name we want to connect to. Well, what happens if this database file, and it's just a file, doesn't exist? It will create it. But if it does exist, it will open it and make it available for us to use. Let's run this statement. As we get into this use case, we're going to be focusing on this area here. See dim customer right here. That's what we're going to be focusing on. We want to create and maintain the master table customer. Now we're going to need a primary key which will uniquely identify each row in the customer table. So it separates each customer. It's important because SQLite is going to use that to determine whether or not it should insert a row or update a row that's already there. Now, the point to understand here is because a primary key is a unique identifier to a row, a database will never let you insert a duplicate primary key, or it's not a good database. So let's start by creating our tables. And before I create our tables, I want to make sure they're not there. So what I'm going to do is say drop table if it exists, customer. And here I'm going to drop custtrans. This is our master table, and this is going to be our incoming transactions. Now I'm going to use my connection object, CONN, and I'm going to use the execute method, and I'm going to pass in a doc string, right? That's a triple quoted string that spans multiple lines. I'm going to say create table customer, and here's where I'm passing in all the columns and data types to SQLite. Now this is really important. The most important thing really that we're doing here is that we are creating a primary key. It's an integer, so it's a number. It says here primary key, and it cannot be null, meaning you must give it a value because, hey, it's an identifier. It's got to have a way to identify. Now we just have our other columns, all our text except yearly income, which is a real. Then we got a strange thing here. We have an ETL last update column. What's that about? Well, it's a date time column, and the purpose of it is that when we go back and look at the data, if we're a data engineer, we know when this row was last changed. We're going to default it to current timestamp. And what that does is when we do an insert, we don't even have to assign it a value because it has a default value. It's going to use the reserve keyword current timestamp to assign it the exact timestamp of that time. So it's going to give it the date time right then and there. We should have a table now. And then we'll import pandas again because I like to do that. And I tend to put the import statements in my cells whether or not I need them because I like to jump around Jupyter notebooks. And sometimes if you don't and you haven't imported a library, it gives you errors. So I like to just keep putting in places so I can do this. To do my queries, I'm going to use the pandas read underscore SQL underscore query. That allows me to just pass my SQL statement straight through like this and get it back. And I just have to pass in the connection object in addition to my query. Now, usually this would be a doc string, but I'm just going to pass a regular string through because it's such a short query here. And what am I doing here? I want to check what's called metadata on a database. Metadata is data that describes other data. Databases are pretty cool in that they have sort of an inventory. What tables do I have? What columns do I have? All these things are tracking. It uses other tables to do that, and those tables have data about data, hence the word metadata. What SQLite uses is a special table called SQLite underscore master. Most databases and the sort of ANSI standard is to have something called information schema. They don't have that. It's a whole schema just for this purpose. But here we have SQLite master, and then we have to filter on the table. And this is going to allow us to confirm whether our master table was created, and we can see it did get created. So that's one way we can do metadata querying in SQLite. Now we got an empty table. That ain't too useful. So let's load it. We're going to load a data frame. We're going to call it custdf. We're going to load it by using pd read CSV, and this data will be available to you. Again, link in the description to get both the data and the notebook. I'm going to bring it in. I'm going to say index col is false. What that means is I don't want to assign any of the columns coming in as the index for the data frame. This has nothing to do with the database table. It's a data frame index. I know, confusing. Just too much duplicate terminology here. So that's going to get returned here to custdf, and then I'll display it. And here we can see my customer table. So we have our customer key here, and our last name, etc. And you can see we have our modified date and stuff, but all we have now is a data frame. We have not put this in a table yet. We need to do that. So let's save the data frame to a table. And this is my favorite bit with using pandas to do SQL work. We don't have to do any special statements. We can just call the data frame method to SQL. Ain't that handy? I love it. And here we can now give it the table name, the connection object, if exists, what to do, and again, index. In this case, we just set index to false and we're good to go. What about this if exists append? Why are we doing that? You have three options here. We can say replace, append, or fail, I believe is the other option. If we say append, it says, okay, take what's ever in the table and just insert these rows onto it. And it won't change the table. But if we say replace, it drops the table and recreates it. And that's a problem because we would lose the primary key definition. By default, when we do the toSQL, it's not going to create a primary key definition for the table. So we're going to use append, and it's going to keep our table definition that we created and just insert our rows from toSQL. Now, the nice thing about this particular format, if you've watched my other videos around using SQL and Python, is that for the most part, it's going to work the same, whether this is SQL Server or Postgres or whatever. The way you open the database and get a connection may change a bit, but the basic way to insert is pretty much the same, even in other databases. So this 2SQL is pretty cool. So let's run it, and then we'll just do this query here to confirm that it worked. And now we're looking not at our data frame, but at the table that has been loaded from the data frame. We can see all this stuff, all these good columns, and we can see our ETL last update date. Now notice that was not in here, right? We don't have that anywhere in our data. It defaulted it for us, and that's pretty handy because I kind of like to be lazy, and it did it for me. And that's the best way to program. I want to show you another way to do metadata querying, and I have a purpose for it because I want to get a list of the columns and data types for customers. So another way to do this type of thing, instead of using the SQLite master table, is to use what's called a pragma. So we just used a query before, right? Read SQL query and then pass our query in. And this is a doc string again. And I'm just saying table info customer. And by doing that, it gives me a nice list back that shows me what's in there, my customer key, last name, etc. All my columns. And I can see that the customer key is set to not null because you must have a value for a primary key, and it's flagged here as primary key. This is all good, but now we have master table. It's got data in it, and the idea would be of the master table. It's probably been there for years, and you're not the one creating it unless you're creating a brand new ETL process. But what I really want to focus on is, suppose you have that and you need to do updates to the master table. That's where the fun begins. So we're going to take our dim customer transaction data, which is in the CSV file, and we're going to load it into transdf, right, our transaction file, just using pd read CSV as before, and we'll just display it, and here you go. So we got some things here. Now I have this special column I added to make it easy to figure out what we're supposed to be doing. You may or may not have this in the real world on a transaction file. I like to have it. If I design it myself, I like to try to put a flag like that because it really makes it easy in the transaction file to figure out what you think should be happening. If I didn't have it, I wouldn't know if any of these are inserts, deletes, or whatever. I'd have to do some extra work on my updates and stuff. So we've got a U means update. So these two rows should be updating, meaning it should match on customer key and then update the other values, right? And what you'll notice here is it's the yearly incomes that changes, among other things. We also have a couple of things that are going to be added, right? Two adds or inserts, which are these numbers. These are not in our data yet, so that's the new stuff. And then we're going to want to delete this row, 11002, Torres. I'm going to delete that. So we have that data in transdf. As before, we're going to use 2SQL to save that to a table we're going to call custtrans. Here's a connection object. And here we're going to say if exists replace. Now, we don't have to have any special metadata for the table that's the transaction table. We don't really need to call any column a primary key, so I'm not going to bother. I'm just going to use this directly. SQLite behind the scenes actually does create a primary key of its own for its internal use, but we're not going to worry about that. We're going to say replace because, again, we don't need to define a primary key on the transaction table. So we can get away with replace. Bear in mind, that means the table, if it was there, would be deleted and then recreated based on whatever pandas wants to do to create this table custtrans. And here I'm going to then query the data frame back. So we're going to automatically use 2SQL to create a custtrans table and then view the data. And there it is. So it worked pretty well, and everything looks to be in order. We could see, we have to have a modified dates. Now, interesting thing about the modified date is sometimes in systems, you might think that seems strange, but it's possible that you're going to get data from a source system, and the data you're getting is actually older than the data you have in your data warehouse. But it's good to trap for it. So what we'll do when we get there is we're going to make sure that the transaction modified date coming from a source system is not older than what we already have on our master table. So let's look at the 3 types of things we may do with the transaction data. We can add, so if the customer is not found, then we add them. We can change it. So if we do find that customer key on the table, we'll update the information. Or we can delete it. And we're only going to do that if the customer is on the table and the action indicator in their transaction table is set to D. The upsert statement is really just a modification of the normal insert statement. As usual, we start with insert. Now I'm just storing this all just so you see it as a doc string, and it's going to go into this value SQL, right? Doc string, nothing special. And I'm going to pull this out here because I want to demonstrate something to you. But let's walk through the whole thing. We're going to have insert into customer. Customer is our master table. That's the table we want to do maintenance on, right? And then we pass it all the column names in the table that we want to insert or update. Now, you don't necessarily have to provide all columns in the table normally because you may have columns that can have null values. But it is a good idea to specify the column names. Here, we have the column names that were coming from our transaction table. So this query is where we're going to get our transaction data from our CustTrans table, right? And we're selecting the same columns from CustTrans as we want to update in customer. Key thing here is normally we could kind of just do this and we'd be done, right? All set. But we want to do an update or an insert. And the way we control that is with this line right here, on conflict. What does that mean? Well, we have this key, right? Customer key cannot be duplicated. You'll get a violation. It's a conflict. So what it says here is on conflict of our customer key, meaning you're trying to insert it, but hey, it's already there, then you can't do that. So you're saying on this statement, if that happens, do this, which is an update. And we're going to say do an update and set, and then you just tell it how to set the columns. Now on the left side are our columns from CustTrans. Makes sense. On the right side are the columns from the transaction table coming in. What's interesting is SQLite automatically prefixes them with this alias called excluded. So excluded.lastname is the last name from the customer trans table. Excluded.marital status is the marital status from the customer trans table, etc. And then you can see, well, what about our last update date? Well, we're going to update that as well with current timestamp. Now, it may seem a little confusing, like, well, it's inserted. Why do we need to go back to it? Because right now, when we're doing this update, if we just update the other column, then the ETL last update is going to have the insert date on it. And that's going to be misleading because it's going to look like, oh, the last time this was changed was 2 years ago. But in reality, the date has changed since then. And we need to know that. That's really important from a data engineering standpoint because when data changes, that's when the risk of problems is occurring. Maybe some values get misset. Maybe there was a bad feed and you got bogus values somewhere. So we just have to assign it current timestamp. That's a reserved value, a keyword in SQLite. So we're good to go there. What is this doing right here? Remember, it's possible that the data from our source system is actually older than the data we already have on our warehouse. What we're going to do to avoid that problem is we're going to check if the excluded.modify date is greater than our customer, which is what we have here, right? Our customer table, modify date. Then we're going to allow this to happen. The update can happen. Otherwise, we're not going to do the update. And I added this extra line. And I want to show you something specific to this, but I'm also adding this and excluded.action indicator is in A or U because the delete's also coming through. And if we don't do this, then the delete's going to be treated as an update because the row should be there, but in reality, we want to delete it. So let's add this, and then we won't be unnecessarily updating rows that are to be deleted. And this is, again, just going to set the SQL statement for us. It shows us it there, suitable for framing. But let's run it now. Oh, no, we got an error. Notice what it says here. There's no such column, excluded.action indicator. Well, why is that? All right, let's go up here. Well, we didn't select it, right? It's not there. But there's a problem. It's not in the master table, so we can't bring it in. Because if we added it to this, it's going to say you have mismatch. You're bringing in a column in your source data. It's not in the master. So we have a problem. We really can't do this. So we'll have to pull it out. Now, that does mean we have an inefficiency here because we're going to be doing updates to data that's going to be deleted. On the one hand, it deleted data. Who cares? But in reality, it's not a good idea, especially if there are a lot of rows that's kind of adding overhead. But we're going to let it go this time. One way to avoid that would be sort of, you could add a filter criteria on this to say only where the action indicator is in an A or U. But I'm just going to let it go. So let's go here. And we should be able to execute that now. And we did. And here we're going to do a check on our customer trans data so we can compare that to our customer data. And we can see that we wanted to do an update here. And this is 11001 Jones. We can see it here. The incomes work. Everything seems to be matching. So it looks like the update took place. We also have an update here. 11,000 Yang. That looks good. Looks like it updated everything. Good. Then we have our ads. We're going to insert these rows, right? And these are 33001. Now, we had nothing like that before, but you can see now those are added, so those are good. What about this one? This is our delete, right? Torres should be deleted, 11002. Oh, no, it's still there. So we have that dangling task we need to do. Let's get rid of Torres. So here we're going to say delete from customer, where customer key in. And this is where it gets kind of cool. We're just going to pass a query in here. It's going to return a list of customer keys from customer trends where the action end is D. Action end means action indicated. What are we supposed to be doing with this? So that'll delete it, and then we can do a select, and it should have gotten rid of Torres. And you can see no more 11002. So Torres is gone. That's about it for this. So we can wrap up our database and close it off. So wrapping up, we talked about what is an upsert and why do I care? And we learned that an upsert is just kind of a convenience. It allows us to do two things in one statement, an insert and an update. And it can be more effective and efficient. It allows us to avoid having to create two sets of logic to do the same thing. Talked about the tools of the trade, and I just wanted to mention that sort of separately. Go out and get SQLite Studio. It's worth having. And I did my riveting tutorial using the upsert statement, and I showed you that it's pretty easy to use. That's it for this time. I want to thank you for watching. Please click on the like button if you liked the video. Make comments. I'm glad to answer questions and see what you thought of this. Until next time, I'm pulling for all this together.